Hi children, welcome to today's class. Today I am going to revise you 3 chapters that are chapter 12, 13, 14. What is chapter 12? Algebraic Expression. Chapter 12 is here. Algebraic Expression. In this topic, what did you see in the previous classes? Algebraic expression. What are the things you have seen in this topic in the previous classes? What is expression? What is variable? What is constant? What is coefficient? What are the types of expression? Then equation, solution. These are the words you would have seen. Yes or no? Just these are the technical words in this topic you are learnt. Just I am recalling what is what. Clear? See, if you take this, see 2x plus 3. Actually, what is 2x plus 3? 2x plus 3 is an expression. Here, x and some numbers, alphabets and numbers are connected here. That alphabet is called, that means this part is called variable. This part, number part, is called constant. That connected with some operations. That combination is called an expression. That combination is called an expression. Actually, what I am trying to tell here, the combination of the collection of variables and constant connected with some operations, addition, subtraction, multiple, division, is called an expression. In arithmetic also we can say 4 plus 3 minus 5. Some numbers are connected with some operations. That statement is called an expression, especially numerically. Numbers only involved there. So we can tell them as numerical expression in arithmetic. That means in number system category. Okay. Here algebraically if you see, variables, that alphabets are mingled here, so that this type of expression is called an algebraical expression. Algebraic expression. Actually, what is algebraic expression? The combination of the group of variables and constants connected with some operations is called an algebraic expression. Here, this is one part, this is another part. Each part is called a term. Each part is called a term. Here this is variable term, this is constant term. Two terms are joined with some operations. Okay. Actually, what is variable term? Actually, variable is a value but which is not fixed. Not fixed one. Variable is a value which is not fixed. Throughout the calculation, it takes various values, so that it is called variable. It can be denoted by alphabets. Okay, variable is a value which is not a fixed. Is called variable. It can be denoted by alphabets. Another one, constant. It is a value, but throughout the calculation, it is a fixed one. It is a fixed value. It constantly will be there. This is not fixed value. It takes various values, so that it is called variable. It is called constant. Each part is called term. This is one term, that is one term. Understood, children? So now, what do you tell? What is algebraic expression? Algebraic expression is a statement containing variable and constant with some operations. Okay, connected each other with some operations is called an expression. For example, 5x minus 4. This is one expression. Here 5x is the variable term, minus 4 is the constant term. Variable, yeah, here x is not a fixed one, it takes various values. 4 is the fixed one. Understood? What about this? 5 in this term, 5 into x only 5x. 5 into x only 5x. That means 5 and x are called factors of the term 5x. What are these? Factors. For example, 10 means how you are telling? 5 into 2, no? 5 2s are 10. 5 and 2 are called factors of 10. Like that, 5x is the variable term. Here we can be split the 5 and x as in multiple notation like this, 5 into x only 5x. 5 and x are called factors. That 5 is called here coefficient. What is that? Coefficient. Coefficient of the variable x here. Understood? So 5x is the variable term. 5 and x are connected with the multiple. They are called factors of the term 5x. Here especially 5 is called coefficient. Understood? Now after that, types of expression and only one term means what do you call? Monomial. 3x, simply only one term is there. So it is called monomial. Monomial expression. 2x minus 5, 2 terms, this is one term, this is another term, 2 terms, binomial. More than that, this is trinomial, 3 terms especially trinomial. More than that and all, polynomial, that and all you would have seen already. According to the terms in the expression, it is classified as monomial, binomial, trinomial, more than that called as polynomial. Understood? After that, what did you see related algebraically in this topic? See, expression to statement, statement to expression, then addition, subtraction, like terms, unlike terms, that and all you have seen in 12.1. Yes or no? In 12.1, how to change expression to statement, statement to expression, identify the terms, factors, coefficients, then the types of expressions. After that, like terms, unlike terms. See here, actually this is expression. How do you write this in statement? Expression, statement. See, without changing this meaning, we have to write. Anyway, as you are this, you can write. But the meaning should be proper, should not be changed. 4 is subtracted from the term 5x. Like that we can write. 4 is subtracted from 5x. Otherwise, difference. What is the clue word for subtraction? Difference we can say, no? So, difference between 5 times of a number x and 4, like that also we can tell. Difference between 5 times of a number x and 4, like that we can tell. Otherwise, 4 is subtracted from 5x, right? 4 is subtracted from 5 times x. 4 is subtracted from 5 times x. Without changing that meaning, you should write in words. That form is called statement form. Shortly if you write, that is called expression. So in this way, change statement to expression, expression to statement. That model is there. After that, types of expression you know, then identify the terms and the factors. See, for example, 5x cube minus y square, like that is there. Identify the terms in the given expression. Terms, factors. Write them. How do you write? Here what are the terms? This is one term, this is one term. Actually term means what? A part in an expression is called a term. Each part is called term. Here 5x cube is one term, minus y square is another term. So 5x cube with the symbol, sign you have to take minus y square. This is another term. What are the factors? Just now I explained, no, factors in multiple notation you have to split and write. How do you split this? 5 into x into x into x. Yes or no? Then only comes correctly. 5 times the cube of x. 5 into x into x into x. So here these are the factors of the term 5x cube. Clear? Then minus y square, how do you write? Minus 1 into, minus 1 into y only, minus y square. So simply you can write like this also, minus y into y. These are the factors of the term minus y square. Here what is the coefficient? Minus 1. No number means how do you consider it? There is one time it is present. Like that you have to take. So minus 1 is the coefficient of the term y square. 5 is the coefficient of the term 5x cube. Clear? Factors means like the split and right. What are the factors of 5x cube? 5 comma x comma x comma x. Minus y square means minus 1 comma y like that. So identify the terms and the factors in the given expression. After that, like terms, unlike terms. Actually what are like terms? Like terms, the terms which have same variable with the same power are called like terms. What are that? Same variable x with the same powers are called like terms. Unlike means oppositely, like opposite only, unlike. So for that definition oppositely you have to tell here. How do you write? Like this. The different variables with the different powers are called unlike terms. Here same variables with the same powers are called like terms. Here different variables with the different powers are called unlike terms. Understood or not? Pick up the like terms from the following expressions like that given. So just revise the exercise sums. After that 12.2, what is given? How to add the two expressions, how to subtract the expressions. How to add a normal addition only, but integer calculation you have to apply here. Simplify. Simplify the given terms. 21b minus 32 plus 7b minus 20b. 21b minus 32 plus 7b minus 20b. We have to simplify combining like terms. Just now I told like terms means the terms which have same variables with the same powers are called like terms. Here b, 21b, 7b minus 20b are like terms only. This is constant term. Okay, leave it. So simplify this by combining like 21b plus 7b minus 20b. Like terms, same variable b, 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 their powers are same. Okay, these are like terms. Constant terms separately take and write. Okay, simplify this. Now take their coefficient only. Plus 21 plus 7 minus 20 plus 21 plus 7. What comes? Plus 28 plus 28 minus 20 plus 28 minus 20. What answer? 8. So 8b. 8b with, actually this is a variable term. Constant term which is present minus 32 only. For minus 32 there is no pair, there is no number. So just as it is, keep with you. You should not simplify this. Why? Because this is variable part, this is constant part. We can't simplify them together. Just we can keep them as nearer. Together we can keep. We can't simplify those. Why? This is variable part, this is constant part. Understood? Then see one more sum I am trying here. Add in addition wise one more. A plus b minus 3, a plus b minus 3, b minus a plus 3, b minus a plus 3, a minus b plus 3. 3 expressions are given, 3 also 3 parts are contained, trinomial. Okay, a plus b minus 3, b minus a plus 3, a minus b plus 3. How to add? Just vertically arrange this. A plus b minus 3. Second part, take this. B, where comes combining, what condition? Before going to add, we must collect them like terms wise. First collect their like terms, arrange it properly and then try to add. Okay, so here B minus A plus 3 means where I should write this B? In B column. B, A minus A, here in A line, minus A, no sign in front, you have to consider as positive, plus sign, plus B minus A plus 3. See, all my A's category in one line, B's category one line, constant category one line. Go to next, A minus B plus 3, A minus B plus 3. So vertically I have arranged all those. Clear? A plus B minus 3, B minus B minus A plus 3, A minus B plus 3. So first of all arrange them like terms wise and then add. See, no number in front of the variable, how do you consider? 1. Here coefficient is 1. Here coefficient is minus 1. Here coefficient is plus 1. So plus 1 minus 1 plus 1. Plus 1 minus 1 gets 0. Cancel. So remainder 1A is available. A. Plus 1 plus 1. Totally plus 2. Plus 2 minus 1 plus 1B. Plus 3 minus 3 plus 3. Cancel. That means 0. Remainder plus 3 only. So A, final answer for this A plus B plus 3. Like that only. This is vertical arrangement wise added. Suppose horizontally if you want to add, how to add A plus B minus 3 plus B minus A plus 3 plus A minus B plus 3. Horizontal addition. Any one method you can follow. See, here also the same procedure, like terms combine first. A in this group minus A in this group plus A. A part taken one side plus B. B minus B minus plus B plus B. No sign, you have to consider as positive. Plus B minus B. Plus constant minus 3 plus 3 plus 3. What comes? Plus minus, cancel A only. Plus 1 plus 2. With that 1 cancel, so plus B only here also. Anyhow answer will come equal only. This is vertical arrangement, that is horizontal arrangement. Understood? Subtraction means which to be taken there, additive inverse of the second one you should take. See, subtraction wise one sum I am putting. Subtract this from that. 6xy, subtract 6xy from 12xy minus 12xy. Subtract 6xy from minus 12xy. What to do? From, what is this meaning actually, ma? Subtract this. Which to be subtracted? 6xy only to be subtracted. From which? From that. So here from this we have to subtract this. So in addition we can add them numbers in any way. 2 plus 3, 3 plus 2, both same only. But in subtraction 3 minus 2, 2 minus 3 gives different answers. Yes or no? Both are not equal. So keep it in mind. Subtract this from that means you should take that only as the first one. So minus 12xy subtract plus 6xy. It gives meaning like this. Subtract this from that. So take it as first. Subtraction. And then this. Now subtract. Subtraction means which is the integer rule of subtraction. Additive inverse of the second one to be taken and add with the first one. Okay, that is the procedure. That means what I am trying to tell. Plus minus 12xy subtract 6xy. which is being subtracted, that sign to be changed. That means additive inverse of that one, plus 6xy. Additive inverse means minus 6xy. Clear? And then add. So here minus 12, actually original beginning level, that sign is positive. While subtracting, that sign to be changed. That means additive inverse you have to take. Plus 6. What is that additive inverse? Minus 6. Minus 8. What is that additive inverse? Plus 8. So that sign to be changed. Okay. Now minus 12xy minus 6xy. In integer, same sign gives what answer? You have to add the numbers, apply the same sign. Different means you should subtract and apply the bigger number sign. This is the integer rule of addition of numbers. Okay. So here same sign means we have to add 12 plus 6, 18 with the same variables xy. So minus 18xy comes. One more little bit bigger level I am trying. Remaining you have to take practice. See, from the sum of 3x minus y, from the sum of 3x minus y plus 11 and minus y minus 11, subtract 3x minus y minus 11. What is the question, pa? From the sum of this and this, from the sum of this and this, subtract that. What is this meaning? What it is telling you? First of all, you have to add both expressions. From that answer, you have to eliminate that. This is the meaning of the given question. So what to do? Take this first. So 3x minus y plus 11. Second part, what is given? Minus y. Where I should write? In y place. Minus y minus 11. Both I have to add. For addition, no need to change the additive inverse of the second expression, which is being added. Clear? Where you should take additive inverse means only subtraction category. Okay, here you have to add only 3x. For this no pair, as it is comes minus 1 minus 1. Coefficient is here 1 only, no? Minus 1 minus 1. Same sign means you have to add. So minus 2y plus 11 minus 11. Cancel. Answer 0. No need to enter. Clear? 3x minus y plus 11 minus y minus 11. What is that answer means? 3x minus 2y. Now we added. From this answer, we should subtract the third one. So what is that? This answer is 3x minus 2y. From this, which I am going to subtract? The given part. 3x minus y minus 11. Subtraction. Here what to do? Keep it in mind. While subtracting any integer from other expression, we should change the additive inverse of the second one and then add. So additive inverse of the second expression, plus sign means consider positive, negative. Plus means that additive inverse minus, write the under, minus, plus, minus. Here also plus. Additive inverse of the second expression I have taken. After that, what I am going to do? I am going to add this with this. Add plus 3 minus 3. What answer? Plus with minus both will cancel, no? So answer is 0x. No need to enter. Minus 2 plus 1 plus 1y. Minus 2 plus 1. See, different sign. Same sign means we added minus 1 minus 1 minus 1. Same sign time I have added and applied the same sign. Different sign means we should subtract. So 2 minus 1 1 and apply the bigger number sign. So negative. So minus y. Clear? Here no pair. So as it is will come plus 11. This we changed no additive inverse as positive, so plus 11. Minus y plus 11 is the answer for this question. What is the question first? From the sum of this and this, subtract that. So what I did first, I have added the first two expressions. From that answer, I have subtracted the third expression. At the time, my answer was minus y plus 11. Understood? Like this, remaining questions you take practice. The third part, finding the value of an expression. How to find the value of the given expression? See, 12.3, if m equal to 2, find the value of 3m square minus 2m minus 7. 3m square minus 2m minus 7. How to add here? Sorry, how to find out this value? Putting m as 2, what to do? See, actually 3m square, how do you write? 3 into m only, 3m square. Clear? 3 into m, 3m square. So if m value is 2, what comes? 3 into, in the place of m you have to apply 2 into 2. So here 3 into 2 the whole square. In the place of m I have to apply the value 2. Minus 2 into m only, 2 minus 2m. So minus 2 into m value 2. With that minus 7 as it is. Apply 2 square. 2 2s are 4, no? 4 into 3, 12. Minus 2 2s are 4, minus 7. So plus 12, minus 4, minus 7. Minus 4, minus 7. Same sign we should add. So 7 plus 4, 11. Same sign apply. So minus 7, minus 4, minus 11. So minus 11 is coming for this. With that 12 is in front. So 12 minus 11 plus 12 minus 11. Different sign. So we should subtract 12 minus 11, 1. Bigger number sign is positive. So plus 1. Understood? So like this only you have to find out the value of the given expression while taking the value of the variable. Clear? That's all, children. Algebraically, whatever given, I have recalled. The next chapter is chapter 13, exponents and powers. We will see lightly. What did you see in this topic? Exponents and powers. What are exponents? What are powers? Exponents and powers. See, 7 square. 7 square. You know well. How do you write 7 into 7 only? 7 square. 7 into 7 only can be written as 7 power 2. Here the 7 square is called exponential form. What is it called? Exponential form. Exponential form. In that 7 is called base. 7 is called base. The 2 is called exponent or power. 2 is called exponent or power. Understood or not? See, while multiplying the any number by itself, we can that time we can write that answer in short form using exponential form. Clear? See, a cube. What is this meaning? A into a into a. That number is multiplied by itself 3 times. In short, how do you write that? Using power notation. That means exponential form. A cube. Here a is called base. That 3 is called exponent or power. That together that formation is called an exponential form. Understood? So in this basis some laws you have learnt, I think. Yes or no? What are the laws? For formula you have learnt here. So before going to see the laws, some values based on the power notation given. Find out the value of the given exponential form. What to do? See, 5 cube. Find this value. What is this meaning actually? 5 can be multiplied by itself 3 times. Yes or no? 5 into 5 into 5. What is this value? 5 5s are 25. 25 5s are 125. So 5 cube value is 125. Understood? So in this basis 13.1 is there. Now oppositely, product form given, write in exponential form. Express the following in the exponential form. See, t into t into t into 5 into 5. Product form given. Write this in exponential form. How do you write? T can be written as, in power notation, t cube. Yes or no? Into 5 can be written as 5 square. This and that, simply this is variable, this is constant. So we can't simplify, just we can keep them together. So t cube into 5 square, t cube 5 square, that's all. Understood children? So like this, remaining questions you have to solve. Then third section in exercise 13.1, express each of the following numbers using exponential notation. Express each of the following numbers using exponential notation. So just some numbers given in 3-digit or 4-digit level. You have to write them in power notation. How to do? See, 128. 128 is a 3-digit number. You know, that can be written in exponential form. In which way? First of all, we have to find out these factors, no? Prime factors we have to find out. What to do? How to find its prime factors? Even number, no? So try by 2. 12. In 12, how many 2s are there? 6 2s are 12. No remainder, go to next. 8. In 8, how many 2s are? 4 2s are. So 64 2s are 128. Again, this is a composite number, so you try divide again by even, no? So try by 2. 3 2s are 6, 2 2s are 4, 32 2s are 64. Again, this is the composite, we should divide. Even number, try by 2. 1 2 is 2, remainder 1, 12, 16, in 12 how many 2s are there? Means 6. 6 2s are 12, 16 2s are 32. Composite, divide again by 2. 8 2s are 16, 4 2s are 8. 2 2s are 4, 1 2 is 2. So that's all. We completed up to least number came. Now what are the prime factors of 128? Prime factors. So 2 into 2 into 2 into how many 2s? 1 2 3 4 5 6 7. Clear? 2 into 2 into 2 into 2 into 2 into 2. Power notation they asked, no? So 2 is multiplied by itself how many times? 7 times. So 2 power 7. This is now exponential form. That's all. So what is given? Just a 3-digit number I took. I found prime factors for that and then written in exponential form. This is a procedure. So like this you try. Then comparison of exponential numbers given, which is greater than that, like that given. One more sum I am trying. Say 3 square 2 cube, which is bigger, this or that. What to do? 3 square, what is that meaning? 3 into 3, 3 3s are 9. 2 cube, what is that meaning? 2 into 2 into 2, 2 2s are 4, 4 2s are 8. 9 is bigger than 8. Therefore we can decide 3 square is greater than 2 cube. Clear? So next simplify also is there, just to try. This is a procedure. Then laws of exponents. Some formula given here to solve the bigger exponential numbers. See, what are that? a power m into a power n is equal to a power m plus n. What is this meaning? In multiple, if the base are same, their powers can be added. What is that meaning, pa? In multiple, if the while multiplying two exponential numbers, what to do? No need to multiply that. Just using the law, we can simplify easily. What that law is telling here, in multiple, if their bases are same, their powers can be added. Here in general, a is the whole number that m and n are, sorry, a is here integer minus 2 power 3, like that we can tell. Okay, a is integer, m and n are whole numbers, integer, that also comes in integer category. See, minus 2 power minus 5, like that. Here minus 5 is integer, no? So a, m, n are here integers. Second law means, how do you tell? A power m divided by a power n is equal to a power m minus n. In division, if the base are same, their powers can be subtracted. In division, if the base are same, their powers can be subtracted. Third law, a power m into b power m is equal to a into b the whole power m. What is the difference between first and third? In first, base are same, powers are different. Here in third, multiple category only, powers are same, their bases are different. At that time, what is the result? A power m into b power m equal to a into b the whole power m. In multiple, if the powers are same, their base to be multiplied and take the power as the common term, common power of the product. A power m into b power m equal to a into b the whole power m. Likewise, for division, a power m divided by b power m is equal to a divided by b the whole power m. In division, powers are same means the take as common power for their quotient. A divided by b the whole power m. Take the power as the common power. Understood? Then fifth law, anything power 0 equal to 1. Anything power 0 equal to 1. Then sixth one, power of a power. A power m the whole power n is equal to a power m into n. A power m the whole power n is equal to a power m into n. Power, for that one more power. At the time, what to do? Powers can be multiplied. Okay, anything power 0. For example, 5 power 0 become 1, like this. Okay, a power 0 equal to 1. So, using these laws only, we are going to simplify the next exponential forms, whichever given in next exercise. See, simplify and write the answer in exponential form. 3 power 7 divided by 3 square into 3 power 5. Given like this, 3 power 7, how do you read it? 3 power 7 divided by 3 power 2, nothing but 3 square into 3 power 5. We have to simplify using the law and write the answer in exponential form. Okay, so how to simplify? First of all, which law is suitable here? Take the group first. 3 power 7 divided by 3 square. So which division, their bases are same? That means which law is applicable there? Second law. In division, bases are same, powers are different. So matching with that, so using this law we can simplify. So 3 power 7 divided by 3 square is equal to 3 power 7 minus 2. In division, base are same, their powers can be subtracted, m minus n. So that I took that into 3 power 5 as it is I have taken. Now simplify 3 power 7 minus 2. What comes? 7 minus 2, 5, no? Okay, into 3 power 5. Simplify. This answer is this one. This as it is I have taken down. Now multiple. In multiple base are same. That means which law is suitable as for the first? Multiple base are same, so power can be added. So using the first law, I can write the step as in short 5 plus 5 like this. This is my answer. 3 power 5 into 3 power 5 is equal to 3 power 5 plus 5 is equal to 3 power 10. Exponential form I got it. That's all. So it is easiest topic only. Carefully you have to select the law and simplify and write the answer in exponential form. Okay ma. Then try remaining sums and all using laws in this way. Then next chapter 14th one, symmetry, very easiest topic. Already in 6th standard you have learnt only. What is symmetry? What are the topic you have seen there? Symmetry. See, two figures are within a figure. If we cut or fold the figure into two halves, each half is exactly matched with the other one. That means that figure is called a symmetrical figure. What I am trying to tell, if a figure is cut or folded into two halves, that time each half is exactly matched with the other, like this. One more hand I am going to keep here. Now both are exactly matching with the other. So these are in symmetrical shape. Okay. So what I am trying to tell here, a figure is cut or folded into two equal pieces such that each piece is exactly matched with the other is called a symmetrical figure. Here the line which is cutting the figure into two halves to match with the other is called line of symmetry or axis of symmetry. Line or axis. Line of symmetry or axis of symmetry. For example, see, here this line is cutting the figure into two halves such that both are matching with the other. That means the figure is symmetrical figure. That line is called a line of symmetry or axis of symmetry. That line can be made in different ways. This is now in standing position, so it is called a vertical line. Horizontal also comes. This is horizontal line of symmetry. Understood? So what I am trying to tell here, the figure is cut into two pieces or folded into two pieces such that each piece is exactly matched with the other is called a symmetrical figure. The line which is making that figure into two halves is called a line of symmetry or axis of symmetry. Instead, line, if you keep mirror, if you keep mirror here, that is called a mirror symmetry. Very close to line of symmetry only. Mirror reflection. Okay. Instead line, if you keep there mirror, it is called a mirror symmetry. Mirror reflection also we can tell. Like this, number of lines of symmetry is there. In plane figures, number of lines of symmetry. See, plane figures means what are the plane figures? Square, rectangle, circle, triangle. Okay, here number of lines of symmetry. Number of lines of symmetry. See, square, all the sides are equal, no? So this is vertical. Horizontal also we can make, diagonals we can make. So here 4 lines of symmetry will come. Rectangle, 2 lines only. Circle, through center we can make lot of lines. So many lines of symmetry it contain. One more thing I try to tell. See, through center which line is passing and touching two ends is called diameter. In circle we will say, yes or no? Here line of symmetry is the diameter only. In the circle, which is the line of symmetry means its diameter only. It only cutting the figure into two pieces exactly. So the diameter is called here line of symmetry. What is the other name of line of symmetry for the circle? What do you say? Diameter. Here triangle, actually sides wise it has three types, no? Scalene, isosceles, equilateral. If the figure is equilateral, there are three lines of symmetry. Okay. If the figure is isosceles, there is one line of symmetry. If the figure is scalene, no line of symmetry. Understood? Then suppose if the figure is regular, actually what is regular? So many times I told that the figure which have equal sides and equal angles are called regular. A figure which have all the sides and angles equally called regular polygon. See, triangle means equilateral triangle only, regular triangle. Square, quadrilateral category. See what I am trying to tell. Regular. What is regular polygon? A figure which have all the sides and the angles equal. All the sides and all the angles equal is called a regular polygon. Three is triangle based, which is regular means equilateral triangle only. Regular triangle. Quadrilateral means four-sided polygon. No, in that many types are there: square, rectangle, rhombus, parallelogram, trapezium. These are quadrilateral category. In this, which is the regular quadrilateral means square only. Okay, it has four lines of symmetry. Equilateral triangle has three sides. If the figure is regular, in triangle category, which classification will come means equilateral. So just now I told you equilateral triangle has three lines of symmetry. In quadrilateral category, which is the regular polygon means square. Square had four lines of symmetry. Like that pentagon, five sides. If the figure is regular means all the sides, all the angles are equal, means that figure is called a regular polygon. Here it has five sides, so it is called pentagon. Regular pentagon. So regular pentagon has dash lines of symmetry means five lines of symmetry. Hexagon, six lines of symmetry. Approximately I am drawing. So if the figure is regular, it is called a regular hexagon. There how many lines of symmetry means six lines of symmetry. See what do you observe from this? If the figure is regular polygon, how many sides it has, that much lines of symmetry it contains. This is the conclusion for this topic. What I am trying to tell. If the figure is regular polygon, how many lines of symmetry comes means according to the sides it contains. See, equilateral triangle is the regular triangle having three sides. At that time that line of symmetry is 3. Square is the regular quadrilateral. It has four sides. So it has four lines of symmetry. Pentagon has five sides. Regular pentagon means it has five lines of symmetry. Hexagon, six-sided polygon. If it is regular, it is called a regular hexagon. At that time, this line of symmetry is 6. So, in general, n-sided regular polygon has dash lines of symmetry. What do you give? What answer will you give at that time? N lines of symmetry. How many sides it contains, that much lines of symmetry it has. Understood? In general, if the figure is a regular polygon containing n sides, how many lines of symmetry it contains? This is the question. What is the answer for that? That much n line of symmetry. N side means n line of symmetry. For example, n equal to 3. 3 3 lines of symmetry. N equal to 5 lines of symmetry. Understood? Like this, exercise 14.1 you have to complete. Just go through that. State the number of lines of symmetry for the following figures. First one, an equilateral triangle. How many lines of symmetry? 3. An isosceles triangle, 1 line of symmetry. Scalene, no lines of symmetry. Square, 4 lines of symmetry. Rectangle, 2 lines of symmetry. Rhombus, 4 lines of symmetry. Parallelogram, no lines of symmetry. Quadrilateral, no. Regular hexagon, regular word came, so 6 lines of symmetry. Circle, many. Understood? Then mirror reflection based alphabets given, which will come vertically, horizontally, both. Like that is there. Alphabets. What are alphabets? You know well. See, alphabets A, B, C, D, like this. Here line of symmetry, horizontally, vertically, both. Like that they are asking. What to do? Vertically, yeah, A will come. So take and write the letters which come under vertically, horizontally, both. Lines of symmetry based, mirror reflection based they are asking. So pick up like this out of 26 letters which will come vertical category, which will come horizontally, both. Both means H, I, O, X. This will come H. Horizontal, vertical. I also vertical, horizontal. O. Okay. So both category. What are the letters will come? H, I, O, X. Like this you have to pick up. Understood? Remaining angle of rotation, rotational symmetry is there. Just go through. Based in that angle of rotation, order of rotation is there. Just easiest part. Just revise yourself. Almost I have touched lightly. Whatever what are the topics given in the chapter, I recalled. The remaining exercise, whatever I left, just to go through yourself. Based on that worksheet will come. Take practice. Thank you, ma.